Hi, Math 20-1. In this lesson, we are going to look at how to do absolute value functions. So in 7.1, we looked at how to do absolute value with numbers. In 7.2, we're going to look at how to do absolute value functions involving x. So we're going to look at how to graph them given a table of values, graph them given an equation, and then how to write them as a piecewise function. So let's first of all look at what an absolute value function is. So if you take any value of x, and I mean any value can be positive or negative, x can be any real number. If I take the absolute value of any one of those numbers, notice that y will always be a positive value. So no matter what the value of x is, y, when you take the absolute value, will be positive. So if you look at the graph, for any value of x, y is positive, and for any value of negative x, y is also positive. So that's why the domain of an absolute value function is any real number, and the range is any y value greater than, and let's add into equal 0. So let's look at taking this idea and graphing a table of values and then coming up with the actual graph of the function. So if we look at this table of values here, if we were to graph that, we would end up with a parabola. And it would look like that. So let's take the table of values and apply the absolute value to it. So all my x values will stay the same. And my y values, I'm going to take the absolute value. So the function had a y value of 0 and the absolute value of 0. The function had a value of -6. The absolute value of that is +6. The function has a value of 16, -16. The absolute value is +16. And I'll do the same thing for my last two values. So now I can take this table of values and generate the absolute value graph. So all the x values stay the same, but you'll notice now the y values are all positive. So that's one way of graphing the absolute value of x, is by graphing the original function using the table of values and then come up with the table of values for the absolute value. Let's look at the steps for that, what we just did. So we saw that any points below the x-axis were reflected above the x-axis. That's because if I have a negative y value, when I take the absolute value, it becomes positive y. Any points above the x-axis stayed above. That's because the absolute value of positive y stays as positive y. And then points on the x-axis stay on the x-axis. And that's because the absolute value of 0 stays as 0. And this is called invariant points, meaning they stay the same after I take the absolute value. So we're going to use that to graph absolute values. So given the graph f of x, we now want to graph absolute value of f of x, and we're going to follow those steps. So the first thing I'm going to focus on is my invariant points, which are the points on the x-axis. Those points stay the same. And then every point above the axis stays above. So all of these points are going to stay above. So using that point 2 and 5, just to give me a nice shape, it's going to be like this. Okay? And then all the points below the x-axis are going to be reflected above. So all of these points below are going to be reflected above. So I'll just pick a nice point on each side. For example, here, -2 and -3 is going to become -2 and +3, just to give me a little bit of a shape. And then I'll pick the point here, 7 and -5 is going to stay as 7 and now +5, just to give me an idea of the shape of the graph. Okay, so you can see, taking the graph of f of x, how I can come up with the graph of absolute value of f of x. So I want you to do the same thing for this graph here. Just pause the video. When you're done, hit play and compare your solution to mine. So following that same procedure, I'm going to look at the invariant points at -4 and 0. Those are the points on the x-axis. And everything that is above stays above. So I'll use that nice point 2 and 3 to give me a little bit of a shape. And then these points here above stay above. So I'll look at that other nice point, -6 and +3, just to give me a shape of the graph. So now this part here below the x-axis is going to be reflected above. So the point -2 and Negative 3 is going to become negative 2 and positive 3. And then I'll just connect the dots like that. So you can see the domain is going to be x is an element of the reals, and the range is going to be y greater than or equal to 0. So another way to come up with the graph of f of x using an equation of f of x is just to do what we just did. So this first step here is what we have to do. Graph the function of f of x, and then it's the same as the questions before. So let's look at an example like that. So I wanted to graph absolute value of 2x minus 5. So you can see I firstly graphed the line 2x minus 5. I identify the x-axis because it's an invariant point, and those points here stay above the x-axis. And then I look at the points where it's negative, and when I take the absolute value, they get reflected above the x-axis. So this y-intercept at negative 5 becomes a y-intercept at positive 5, and now you can see my positive piece. So domain and range again stay the same. So I graph the original function, identify the positive parts because they stay the same. If it's positive, it stays positive, and then identify the negative parts and reflect them above the x-axis. So I'm going to get you guys to pause the video and try this example, and then when you're done, press play and we'll compare our answers. Okay, so you can see my graph y equals 2x plus 1. It's a nice linear graph, and I'm just going to identify my invariant point here, and all the points above are going to stay the same. And then I'm going to take this negative piece here and I'm going to reflect it above the x-axis. So I just choose one nice point, for example here, negative 3 and negative 5. When I reflect that, it's negative 3 and positive 5. So it's going to be reflected above the x-axis, and that will be my graph with the domain and range shown. Now the second way that you can graph the absolute value of x is to actually just enter the whole equation into the calculator. Once you do that, you can find your intercepts, particularly x-intercepts, and the vertex, and then draw a labeled sketch. So if we look at this one, for example, I'm going to enter in absolute value of 2x minus 5 minus 2 into the graphing calculator, just like that. And the first thing that I did is I found my y-intercept. So I did trace 0 to get my y-intercept at 3, and you can see that I've labeled that on my graph. Then I find my x-intercepts. Remember, I enter in the x-axis, which is y2 equals to 0, and it graphs the x-axis. And then I find the 2 points of intersection, one at 1.5, the other at 3.5. And you can see I've labeled those on my graph as well, 1.5 and 3.5. The only thing I have left to do is calculate my vertex, which, just like a parabola, is your minimum value. So I go into my calculate menu, I calculate the minimum, I show the graph where the left of the vertex is and where the right bound to the right of the vertex is. Press enter and I get a vertex or a minimum at positive 2.5 and negative 2. So you see my nice labeled sketch. Now notice my domain and range has changed a little bit. My domain is still an element of the reals, but since I have a vertical shift outside of the absolute value, I went down to my range is now y greater than or equal to negative 2. So that's changed a little bit. So I want you guys to try this graph on your own. Graph the absolute value of negative 4x minus 3 using method 2. Put it in your calculator, labeling all your points. So press pause on the video and come back when you're ready to compare your answers. Okay, so the first thing I did is I entered it into my graphing calculator there, the absolute value of negative 4x minus 3. And I want to label all my parts. So I'm going to first of all find my y-intercept. And I do that by doing trace 0, and I get a y-intercept at 3. And then I need to figure out my x-intercept, which also happens to be my minimum. So you can calculate either your x-intercept or your minimum because they're the same value. I chose to do my minimum value. So here I labeled it in as negative 0.75 because the minimum you can see here is negative 0.75 and 0. So that would be my graph. Notice my domain, still an element of the reals. This time, since I did not have a vertical shift down, my range stays as y greater than or equal to 0.